Calculating the limit at infinity might not seem straightforward, and understanding what it means can be tricky. In this video, we will not only learn how to calculate limits at infinity, but also explore their physical significance and applications in science and engineering. A limit describes the value a function approaches as the input approaches a specific point. But what happens if we let x grow very large, positively or negatively? That's where limits at infinity come into play. Let's talk about how to calculate limits at infinity. Keep in mind that every time we say infinity, we generally refer to substituting a very large value for x in either the positive or negative sense. Before we start, it's important to remember these key principles. First, if you divide a constant by infinity, the result will be 0. The second, negative infinity multiplied by negative infinity equals positive infinity. Now, to calculate the limit at infinity, we generally start by simplifying the equation as much as possible before we substitute infinity for x. For example, let's evaluate the limit as x approaches infinity of 4x squared plus 3x divided by 16x squared minus x. If you plug infinity directly, you will get infinity over infinity, which is an indeterminate form, meaning the expression cannot be evaluated to a single number. So, we have to simplify the function by factoring out the highest power of x. In this case, after we factor out, we cancel the x squared term, and then we plug x, which results into the following. For more complex equations, you can use these general rules to help you find the limits at infinity. For example, for rational functions, if the numerator's power is less than the denominator's power, the limit is 0. If the degrees are equal, the limit is the ratio of the leading coefficients. Now, let's look at what calculating the limit at infinity represents. Limits at infinity are often used to find horizontal asymptotes. These describe the behavior of functions as it stretches toward infinity. The concept of horizontal asymptote has many important applications in science and engineering. For example, it can help with estimating the maximum growth or decay of populations over time. Additionally, in engineering, horizontal asymptotes can be used to predict the steady-state behavior of systems. For example, in heat transfer, the temperature of an object approaches the ambient temperature over time, a real-world use of limits at infinity. And this is it regarding limits at infinity. If you found this video helpful, be sure to like, subscribe, and share. And don't forget to check our other videos for more insights. Thanks for watching.